Hello students, I Pushpinder Kaur welcome you in the next video lecture based on chapter Alcohol, Phenols and Ether. In this video lecture, we will discuss about the various methods of preparations of alcohols. We can prepare alcohols from alkene, from carbonyl compounds, from alkyl halides and discuss some industrial preparations of the alcohols. Let us discuss these methods of preparations one by one. The first method of preparation of alcohols from alkenes. We can prepare the alcohols from alkene by the hydration. The hydration means the addition of the water. We can add the water into alkenes by the direct hydration methods, in which we use acidic medium as a catalyst. And the second one is the indirect hydration, in which we can use hydroboration-oxidation and the oxymercuration and demercurations of the alkenes. In the direct hydration of the alkenes in the acidic medium, the more reactive alkenes can take up water molecules directly in the presence of the acid catalyst, such as the dilute sulfuric acid, to form alcohols. The such additions follows the Markovitch rule in case of the unsymmetrical alkenes. Let us discuss the mechanism of this process. In the first step, there is a protonation of the alcohol. As ions are unstable, that's why firstly the water molecules can combine with the H positive ions to give the hydronium ion. And in the next step, the pi electron of the alkenes having the greater charge density abstract the proton from this hydronium ion to generate a carbocation, and the water molecules will releases as it is. In the next step, there is a nucleophilic attack of the water on the carbocation, as the atom of the water molecule having the two lone pairs, and these lone pairs act as a nucleophile, and these electrons get attacked on the carbocation. It will generate a intermediate compound, and last step there is a deprotonation of this transition state to form the ethanol. What happen in this case? To complete its charge density, the oxygen will attract the electron from this less electronegative hydrogen and forming a ethanol or the alcohol and generating the hydronium ion at the end of the reaction. The next is the preparation of the alcohols in case of the unsymmetrical alkenes. The addition of the unsymmetrical alkenes take place in the accordance with the Markovitch rule. Like according to the Markovitch rule, electrophilic addition of the alkene, the positive part carbon-carbon double bond that having the greater number of the hydrogen atom, and the negative part will goes to the that carbon atom that have the less number of the hydrogen atom. It means the water molecule that having the H positive ions and the OH negative ions, the H positive ion will go to this CH2 group and making the CH3, and the OH negative ions will get attached to this CH that having the less number of the hydrogen atom. And you can prepare the alcohol by the direct addition of the sulfuric acids also. Like in the sulfuric acid, there are the hydrogen atoms having the partial positive charge, and the charge density on the pi electron get attacked to this H positive ions, making the carbocation, and this sulfate ions will attack on this carbocation to making a sulfonic adduct, and during the hydrolysis of this adduct will give you the alcohol and the sulfuric acid. But there are the few drawbacks of this method. The water follows the Markovitch rule, as in case of the Markovitch rule there is a carbocation formed as a transition state. Therefore, this will leads to the formation of the major and the minor product according to the stability of the carbocation. In the next case, if we are talking about the indirect hydration of the alkene, the first is the hydroboration. In the hydroboration involves the electrophilic addition of the borane. The borane having the formula B2H6 and it having the H negative and the BH2 positive ions, and it will follow the anti-Markovitch rule. According to the anti-Markovitch rule, the H negative ion will goes to the less number of the hydrogen atoms and the BH positive ions will go to the higher number of the hydrogen atom. Addition of the borane on alkene, it will form alkyl borane as the addition product, which undergo the oxidation with the hydrogen peroxide in the presence of the aqueous solution of the sodium hydroxide to form the alcohol. In this case, the first trialkyl borane is formed as a transition state, and the further oxidation of this trialkyl borane in the presence of the sulfuric acid and the base, it will form alcohol and the boric acid. And the next is the oxymercuration and the demercuration of the alkene. Important method for the preparation of the alcohol by the indirect hydration of the alkene. And the product formed in this method do not involve any kind of the rearrangement, but it strictly follow the Markovitch rule for the addition of the water across the double bond. In this addition, alkenes are treated with the mercuric acetate in the tetrahydrofuran solution to form hydroxymercuryl compounds. This step is called as the oxymercuration process. Compounds are reduced by sodium borohydride such as NaBH4 to form alcohols by the replacement of the mercuric acetate group by the hydrogen. In this case, this mercuric acetate ion get replaced by the hydrogen given by the reducing agent sodium borohydride, and it will form the alcohol as a major product. Let us talk about the mechanism of this process. In this case, the mercuric ions having the positive charge, it will attack on the pi electrons of the alkene to give the merconium ion, and after the addition of the water molecules, it will form organomercuryl alcohols, and on the reduction of this alcohol, it leads to the formation of respective alcohols. This is a summary of the all processes. If the sulfuric acid is given, means the propene get hydrated in the presence of the acidic medium, then it will follow the Markovitch rule and give 2-propanol as a major product. And similarly, in the case of the mercuric acetate and the reducing agent, it will also form the according to the Markovitch rule, but in case of the borane oxide in the presence of the base, it will follow the anti-Markovitch rule and give 1-propanol as a major product. These are the few examples based on the indirect hydration. Like in the first case, propene on the mercuration and the demercuration in the presence of mercuric acetate and the sodium borohydride give a Markovitch product, and the name of the product is isopropanol. Similarly, 3,3-dimethyl 1-butene on the mercuration and the demercuration give 3,3-dimethyl 2-butanol as a major product, and in case of the methyl cyclohexane on the mercuration and the demercuration give 1-methyl cyclohexanol as a product. In this case, in the presence of BH3, it will form 2-methyl propanol as a major product. The next method of the preparation of alcohol from carbonyl compounds. The carbonyl compounds are those compounds in which carbon oxygen is present as a functional group, like aldehyde, ketones and the carboxylic acids. We can prepare alcohols from carbonyl compounds by the catalytic reduction and by the action of Grignard reagents. By the catalytic reduction of the carbonyl compounds like aldehyde, ketones and the carboxylic acid converted into the respective alcohols. For example, in case of the ethanol, on treatment with the hydrogen in the presence of the reducing agents such as nickel, platinum, lithium, aluminum hydride, sodium borohydride, to give the primary alcohol as a hydrogenation reaction. Similarly, the ketones on the hydrogenation in the presence of reducing agents such as a nickel, platinum, lithium, aluminum hydride give the secondary alcohol as a major product. Similarly, the carboxylic acid in the presence of reducing agent give a primary alcohol as a major product. Now, the next case is the action of the Grignard reagent on the carbonyl compounds. The main advantages of this process is we can prepare all type of the alcohols by this method. We can prepare the primary alcohols, secondary alcohols and the tertiary alcohols by treating an appropriate aldehyde or ketone with the Grignard reagent in the presence of dry ether, followed by the hydrolysis of the addition product with dilute acid. In this reaction, the first step of the reaction is a nucleophilic addition of the Grignard reagent, as the Grignard reagent is a partially ionic in nature, with the alkyl group having the partial negative charge and the MgX bond having the partial positive charge. Now, carbon and the oxygen being a highly electronegative in nature, attract the electrons towards itself. Therefore, the oxygen having the partial negative charge and the carbon having the partial positive charge. And during the nucleophilic addition reaction, the R negative get attached with the carbon positive and MgX positive get attached with the oxygen negative and making a adduct. And this adduct on the hydrolysis give the respective alcohol in the acidic medium. Like in the acidic medium, the water will give the H positive and the OH negative ions. The H positive ions get attached with this oxygen to give the respective alcohol and removing magnesium halide hydroxide as a byproduct. For example, formaldehyde on the treatment with the Grignard reagent followed by the acidic hydrolysis give the primary alcohol, and the aldehyde on treatment with the Grignard reagent followed by the acidic hydrolysis give the secondary alcohol, and the ketones on the treatment with the Grignard reagent give the tertiary alcohol. Prepare alcohols from the alkyl halides also when heated with the aqueous base are hydrolysis to form alcohol by the nucleophilic substitution reactions. For example, the haloalkanes on treatment with the aqueous base. In the presence of aqueous base, the base will give the OH negative ions. OH negative ions replace this halogen group to give the respective alcohol. This is the substitution reactions. Suffer from a major drawback as it does not give a good amount of the alcohols. Of the alkene is also formed by the loss of the molecules of the halogen acids form tertiary haloalkanes. Amount of alcohol we replace the base with the moist silver oxide, and by treating the alkyl halide with the moist silver oxide give the good amount of the alcohols. The next is the industrial preparation of the alcohols. We can prepare the alcohols by the fermentation method. The fermentation method is the heating of the carbohydrates in the absence of the oxygen. Like the simple sugar molecules on the hydrolysis in the presence of the invertase give the glucose, and the glucose in the presence of the enzyme give ethanol, carbon dioxide and the energy, and this whole process is known as the fermentation process. Similarly, we can prepare the alcohol from the starch, and the starch converted into the glucose in the presence of the biocatalyst, and this glucose can be converted into the ethanol and the carbon dioxide by the biocatalyst. Similarly, on treatment with the oxygen in the ratio of 9:1 at high pressure and temperature in the presence of copper catalyst gave methanol, and the water gas, carbon monoxide and the hydrogen in the on treatment with the hydrogen gas in the ratio of 2:1 at the high pressure, and the chromic oxide and the zinc oxide catalyst give methanol as a major product. These are the some other methods to prepare alcohols. For example, the hydrolysis of the ethers in the acidic medium give alcohols if the halogen acids are present, and if this reaction is carried out in the presence of sulfuric acid, it will give the alcohols as a major product. The next is the hydrolysis of the esters, and esters when treated with the base give the carboxylic salt and alcohol as a major product. This reaction is also known as the saponification reaction. Now this is your homework. You have to classify the given alcohols as a primary, secondary and the tertiary alcohols. Let us suppose this is the alpha carbon atom and this carbon is directly attached to the one carbon atom. So that means this alcohol is the primary alcohol. You have to classify the other alcohols is also primary, secondary and the tertiary alcohols, and you have to identify the allylic alcohols from the above examples. The allylic alcohols are those alcohols in which the functional group, means the hydroxyl group, is directly attached to the next carbon of the carbon-carbon double bond. Now this is also your homework. You have to write down the IUPAC names of the product by the catalytic reduction of the butanol, hydration of the propene in the presence of dilute sulfuric acid, reaction of the propanone with methyl magnesium bromide followed by the hydrolysis reaction. And thank you. Have a nice day.